Good morning, everyone. I am Rakshita. I am here. Basically, our topic is student performance clustering using K-means. Our team members are Apekshan Tonshal, Priya M. Chikeri, Rakshita GR, Rakshita V. Dabadi. Next, my part is introduction. In this education institution, a student performance is influenced by the multiple function include study habit, attendance, and exam result. Traditional evaluation method often fail to recognize patterns among students that could inform personalized learning strategies. Clustering is a machine learning technique used to group in the similar data points. It helps to education by categorizing students based on the learning patterns. The goal is to improve academic strategy using data-driven insights. Next, continued by Priya M. Chikeri.
I am Priya. I am here to explain about methodology, data collection and pre-processing. Data sources. Study as. Study as logins. Records the number of hours students studied per week, indicating their study habits. Exam scores. Exam performance. Finally, exam scores used to evaluate the academic achievements. Attendance. Attendance record shows the percentage of the classes attended, reflecting of the classes attended class participation. Next, data pre-processing steps. Handling missing values. Missing data is filled with the average value of that feature to maintain consistency. Normalize numerical features using minimum and maximum scaling. Data is scaled to range of 0 to 1. Ensure all the features contribute equally during analysis or modeling. Next will be continued by my friend.
Now I am here to explain the implementations. The tools VRB used are the Python, Pandas, Scriptlearn, and the Matplotlib. The key means clustering. The participating the algorithms that can be divided the students into the K groups or based on the features of an similarities. There can be minimized the intercluster distance. The choosing the K is equals to 3 by using the elbows method. The each students can be assigned the clusters labels such as an a 0, 1 or the 2. These labels can be affect the similarities in the behavior and the performance. Visualization and analysis. To create the scatter plot, for example, the student hours versus the exam scores are be colored by the clusters. They can be printed the summarize the statistics, which means the means, minimum and the maximum for the each cluster, such as the high performance at an risk students and the moderate learners. Next slide will be continued my friend Apeksha.
Apeksha, and I will be explaining the initial part of our project on student grouping using K-means clustering. This project shows how K-means clustering can help us group students based on their academic behavior. It helps teachers like identifying the struggling students early, provide personalized interventions, and improving learning outcomes using real data. Next, code. In this code, we have used a few key Python libraries to build our project like Pandas, Matplotlib, and Seaborn for visualizing the data clearly. sklearn clustering k-means, which is the k-means algorithm from sklearn, minimum maximum scalar to normalize the data and bring it into the same range before the clustering. Um, then we used pandas to load our data set using this line of code. Uh, this line of code, data equal to pd dot read csv. Then we have to copy the path. This reads a csv file with the student data. We used a data dot head function to look at the first few rows and understand what we are working with. Now I will hand it over to the Priya.
Now normalizing the data. Scalar is equal to minimum maximum scalar. Creates a minimum maximum scalar object to normalize the data between 0 and 1. Normalized is equal to normalized data is equal to scalar fit. It fits the scalar to the data and transform it into the normalized range. Convert back to the data frame for readability. df normalized is equal to pd data frame. It converts the normalized numpy array back into the data frame with original column names. df normalized displays the normalized data frame as shown in below. Next will be continued by Rakshita Rudraman.
Fit the K-means model to normalize the data and assigns a cluster label to each data point, storing in a new column called cluster. In the df normalized data frame, df normalized displays the updated data frame now including the cluster labels. Print cluster centers. Prints a heading including the cluster centers will be shown in next. Print k-means cluster centers prints the coordinates of the cluster center in a normalized feature space. Next will be continued by Rakshita V. Dabadi.
Visualize clusters. They can be plotted the 2D graphs with an study hours with consider as an x-axis, and the y-axis we can consider the exam scores. They can be colors or be considered as an clusters by the groups. 0 is be considered as an high performance of an students. 1 is be considered as an average, and the 2 is be considered as an below average students. Next, analysis the each clusters. This can be helps to understand the each cluster and the print the statistics like an a mean, minimum and the maximum. With an a clusters of an a 0 high performance and the cluster 1 with an a risk takers and the cluster 2 is an a average students. Output, the cluster 0 which consider as an a high performance, high student hours and the example scores and the attendance. These are the independent learner. They may be benefited by the advanced in the activities, research and the competitions. The moderate students, the average in the study times and the attendance with a moderate of an scores. They need to be structured to study the plan and the regular feedbacks and the motivation, etc. The cluster 2, it is an risk taker with an low of an study attendance and the exam scores. They need to be support maintaining and the remedial classes. The attendance should be monitoring and the counseling are be needed.